To see about the Prim's algorithm. So Prim's algorithm is used to find the minimum spanning tree for a given graph. So let us see first the rules. So the rules for in Prim's algorithm is first we have to remove all the loops and all the parallel edges. And second rule is that we can choose any node as the root node. Say that for a given graph, say with nodes A, B, C, D, E, and F, you can choose any one node as the source node or the root node. Then in the next step, we have to check for all the outgoing edges from the node which we have selected and choose the edge which has got the minimum cost. So we'll apply the same for all the nodes one after the other. So let us see now with an example. So say that we have a graph here, and as the rules says in Prim's algorithm, we have to first remove the parallel edges and the loop. So let us remove the parallel edges of this graph. So here we have got parallel edges. So remove the edge which has got a higher cost. And we have got a loop here. So let us remove the loop and let us redraw the graph, and then we will proceed on. So this is going to be our graph. So A to B, B to D, A to C, C to E, then D to F. And now let us write down the cost of all the edges. So here we are going to take only the minimum edge cost. So 7 and 8. Now let us first find out, here let us take out the source node to be as EA. Okay, so let me first draw the nodes alone. So A, B, C, D, E, and F. Fine. Now we'll start from A. So from node A, what are the paths which are having lesser cost? So A, there are two edges, 7 and 8. So 7 is having a lesser cost. So we'll travel from A to B. Now look at this. So here from B or from A, how do we reach the rest of the other nodes so that we can connect all the nodes with the minimum number of edges? That is how we construct the minimum spanning tree, right? So now from B, check out what are the edges out of the B. So B has got D to C and to A. So this is already being, we have used this edge. So now we have got three paths. So out of these three paths, B to C is the path which has got the lesser cost. So now let us connect B to C. So let us write down the cost also. So 7 and 3. Now either we have to move from B to D or from C to rest of the other nodes. So let us start with C. So for C, there are 4 edges. So out of these 4 edges, we have visited this edge and this edges. So now here C's edges, out of C's edges, the minimum edges from C to E, right? So C to E is 3. So let us take out this edge. So C to E is 3. So out of these 4 edges, this edge is already picked. So now C to E edges picked out. Now just do the same thing. Either we can move out from B or from E. So now let us try out with the E node. So E node, there are two edges which has got the minimal cost. So let us use the two edges of the two nodes. So let us connect out. So D is connected now, and F is also connected now with E. So let us see now whether all the vertices of this graph is connected. Yes, and it has been connected with the minimum spanning tree. Now just analyze with D. So with D, there are 4 edges and only 2 is minimum. So this is the only way, only the minimum edge. So that this is the final minimum spanning tree for this graph. So how do we find the total cost? Is the total cost of this Prim's algorithm is 7 plus 3 plus 3 plus 2 plus 2. So it is going to be 10, 13, 14, 15, 16, 17. So the total cost is 70. So this is the working of the Prim's algorithm. And you can have, and let us see the Prim's algorithm. So, what are the steps which are involved in the Prim's algorithm to create a minimum spanning tree? So, the step one is, first we have to determine the arbitrary starting vertex. So, here in our example, we have taken the starting vertex as A. And now we have to keep repeating the step 3 and 4. So step 3 and 4, what is the step 3 and 4 states at is until the fringe vertex. This fringe vertexes mean the vertices which are not included in the minimum spanning tree. Say when we constructed just A and B, okay, when we constructed just A and B, the rest all of the vertices which are not connected, which are not included in the minimum spanning tree, this all vertices we call it as the fringe vertices. Fine. So now so you have to keep repeating until the fringe vertices remain. So now what is step 3? So in step 3 you have to select an edge which is connecting the tree vertex and the fringe vertex. So we have to connect the tree vertex and the fringe vertex which is having the minimum weight. So once we select the edge, then we can add it to the choose an edge of we can add the choose an edge to the minimum spanning tree if it does not form any closed cycle. So when you connect the edges, so it is not supposed to form a cycle. So cycle is not allowed when you construct the minimum spanning tree. So that is the main point that you have to remember when you draw the minimum spanning tree. So once you have chosen the edge to the MST, and if it does not form a cycle, now the minimum spanning, it can be included under the minimum spanning tree. So this is all about the Prim's algorithm. And now let us see what is the time complexity for this Prim's algorithm. So the time complexity for this Prim's algorithm is order of E log V. So where the E is the number of edges and V is the number of vertices of the graph. So this is the time complexity. So V is the vertices of the graph. Thank you.